Welcome back to Mr. Lamb's Science Corner. Today we're going to take a look at heat conductivity. Okay, so heat conductivity is basically how well is heat transferred from one object to another. We have conductors and we have insulators, and there's some kind of dividing line between the two. We're not going to worry about that. Mostly metals and such are conductors, plastics and such are non-conductors. And we're also going to talk about specific heat. Okay, specific heat. Water is defined as having a specific heat of 1 calorie per gram degree Celsius. In fact, that's how a calorie is defined, is the amount of heat necessary to raise 1 gram of water 1 degree Celsius. If you want to talk about the BTU, which is a British thermal unit, BTU, that is 1 pound of water, the amount of heat necessary to raise 1 pound of water 1 degree Fahrenheit. And since a pound is a lot more than a gram, even though a degree Fahrenheit's less than a degree Celsius, the BTU is really quite a bit larger than a calorie. We can also talk about how the nutritionists have confused things mightily by saying we love the term calorie, we don't like the size of the unit, so we're going to change it. And a food calorie is actually 1,000 regular calories. Okay. Properly, food calories are supposed to be spelled with a capital C. Many nutritionists, I would say, don't bother doing that, even though that's what they agreed to do. So physicists came up with a definition of the term calorie, and nutritionists said, woohoo, we love this. What I have here, I'll hold them up, are 2 black discs. One is made of metal, one is made of plastic. And as we defined, a metal is probably a conductor and a plastic is probably an insulator. And the plastic is going to feel regular because your hand, the nerves don't sense temperature. You've learned to say that's hot, that's cold. What they sense is heat flow. Heat flows out, the object must be cold. Heat flows in, the object must be hot. So when you touch an insulator like a plastic, heat doesn't go anywhere, so you go like, yeah, room temperature, normal temperature. When you touch a metal, especially this one, it's going to feel cold because because of the high conductivity, heat is going to flow out of your hand and you're going to say that's cold. In actual fact, these two are at the same temperature. Okay? And we can show this. These are just little big O-rings here to hold things in place. And if I could get my camera person to focus down on this here. Okay, I'm going to take an ice cube and I'm going to put it here on the plastic. And I'm going to take another ice cube and put it here on the metal. And you can notice that the metal is doing something very unusual. And I'm hoping that it's picked up. It's melting really fast. And the ice on the insulator is doing what you expect. Can we see how the water is now running out and it's going to drip onto the floor, which that's okay. So anyway, the insulator is doing just what you expect, which is basically nothing. It will eventually melt, but not very fast, whereas the ice cube here in the metal is going very quickly. Now, the reason it does this, and this, by the way, feels very cold now, is that this is made of aluminum. And aluminum has 2 properties that allow this to happen. One is it has high thermal conductivity. It conducts heat very well from one spot in the metal to another. And so when you put the ice cube here, heat is going to flow from all over this into the ice cube. And the other part is it happens to have a high specific heat. I should have looked it up. I think it's 0.27, which sounds small compared to that of water, and it is, but in actual fact, it's, if not the highest metal, it's pretty close to it. Of the common metals, certainly the highest. Copper is very, very low. Iron is fairly low. We could just go through all the different metals and look up the numbers and see that they're very, very low compared to aluminum. Aluminum has, if not the highest, one of the highest specific heats for metals. So it stores a fair amount of heat into it. And then that heat is able to flow throughout the metal, so it's going to melt the ice very, very quickly. Whereas over here, there's a little bit, and it feels a little cold right underneath the ice cube, but if you touch elsewhere, it's going to feel what it felt before, because heat doesn't flow very fast through here. Now, these blocks can be bought, I believe these were bought from Flynn Scientific, which I have sung their praises before, and I will continue to sing their praises because I really like Flynn. Like I said, I don't receive any money from them and haven't asked for any, but they do a good job on safety. But this is not. But Flynn is not the only place. There's some other places that you can buy these. They call this amazing ice melting blocks. I don't know if we can. Can we get that? And that may be just Flynn's name, but it's the right idea. And they're not terribly expensive. I will attempt to do this demonstration again using household materials at a later date. But you can get these things, and it's well worth it because they'll last forever. You know, plastic and metal, I mean, they don't go bad. So you can buy this for your school, and you can put it in there, and the kids will really go ooh and ah. So, really quick demo, something you can do, and with that, we say thank you.